长城报告，申请发送主反并网手控指令。
北京明白。神舟19号，我是北京。
神舟19号到。
发送主反并网手控指令。
神舟19号明白。正确。神舟19号报告，主反并网手控指令已发出，完毕。正确。好了是吧？可不行，有个线先拿出来。对对。这个线卡住了，你先拿上，你先拿下来。对。好。往后推一点。好，推。那毛毡看不见。你搜搜。
2分钟后回返分离，2分钟后回返分离，2分钟后回返分离。
不行，我回好。可以吗？你看着啊。还没进去吧？给我吧，给我吧。
调姿指令发布。
长城报告，第一次调姿开始。
依次调姿开始。
长城报告，第一次调姿到位。
依次调姿到位。
轨返分离，轨返分离，轨返分离。
长城报告，轨返分离。
神舟19号报告。
轨返分离。
轨返分离。
第2次调姿指令。
北京明白。
长城报告，第2次调姿开始。
2次调姿开始。
长城报告，第2次调姿到位。
2次调姿到位。
好，动手。好了，好了。
返回开始，返回开始，返回。
长城报告，返回制动开始。
发动机开机，返回制动开始。
开机指令发出，自动发动机开机指令发出。
The capsule has finished a second adjustment of its altitude. Now this is on your left hand of the screen, live footage from the capsule, a return capsule, and on your right side of the screen, you can see that's kind of a simulation of their returning process. And for more insight, we're joined in the studio by Professor Yang Yuguan and Associate Professor Zhang Fan. Thank you very much for joining us, gentlemen. So, as I understand, they finished at least 3 key steps on their way home, right, Professor Yang?
Yes, exactly. So, from the previous video, we can see that although, as you mentioned, it is a 3D animation, but it represents the real-time status of the spaceship. So, at this moment, we have conducting the deorbit burn, which means that we will deaccelerate for a remarkable amount of energy so that the trajectory of the Shenzhou spaceship turn from a circum-Earth orbit to the trajectory which can dive into the atmosphere. So with this very important measure, we can return to the Earth with the help of the aerodynamic forces, which can reduce the speed of the Shenzhou spaceship, and then we can conduct the deployment of the parachute, and then we will back to the Earth.
As we just reported about 5 minutes ago, the capsule has finished actually at least 2 adjustments of its altitude. Why
Exactly.
this is so necessary?
So you know that our Shenzhou spaceship have the 3-module design. So the first step will be the separation of the orbital module, as your colleague already mentioned in the Beijing Flight Control Center. So this is to reduce the total mass of the spaceship. But you know that to avoid any collision, we must separate in a different direction. So that is why we conduct the first attitude maneuver for about 90 degrees in the your direction. And then, you know that for the deacceleration, we must use the main engine on the propulsion module, like we see in the 3D animation now. So this need another attitude maneuver to change the direction to the right one. And then, as we have seen already seen from this video, that according to the commander on the ground, the deorbit maneuver has already been successfully conducted. And now, at this right moment, the Shenzhou spaceship is in the trajectory back to the Earth.
So, talking about the re-entry, Professor Zhang, how challenging is this? Because we've talked about this for at least a dozen times, but every time we need to ask how challenging is this for the very stage of re-entry?
Right, so soon there will be a separation between the service module and the re-entry module.
And sorry, professors, we are seeing actually live footage. This is the Dongfeng Landing Site, right?
Oh, it looks pretty good. I was expecting more wind and sand, actually.
Oh, the weather. You think the weather is relatively favorable, at least today, right?
Right. Yesterday, the threshold is 15 meters per second. Yesterday, they were expecting it to be above that threshold, and today the forecast is still 10 to 12 meters per second. and now it looks like it's not that bad. So the wind would be a major challenge, coming back to your question.
Right.
Because there was a parachute stage.
Yeah.
And if the wind blows, then you can imagine it's like a pendulum underneath a parachute, and if it swings too much, it might go up and the parachute stopped working properly, and that would be the major problem.
Right, and Professor Yang, you're no stranger to this massive landing site in Mongolia, because you're right from that region.
Yes.
Tell us more about the, as Professor just mentioned, sky looks fair, clear, right?
Exactly, it's much better than yesterday. So we can see the on social media the video yesterday. There do have strong wind and also sandstorm yesterday. You cannot see very clear even 100 meters away. So it is the right choice, I believe, according to the formal announcement of China Manned Space Agency. We postponed the landing from yesterday to today, but they do not have much influence or impact to the whole landing procedure. You know that, as you mentioned, I am a native of Inner Mongolia. The landing site is located very close to the Jiuquan Satellite Launch Center, just in Alashan, and also, actually speaking, in the Ejina Banner.
Right.
So the landing site, the total area is more than 13,000 square kilometers. So it's a
Talking about this landing, sorry to interrupt you right there, we can also see that live footage from the Tiangong Space Station.
Yes.
The Shenzhou-20 crew
is watching the live
Taken out,
coverage
yeah.
of CMG.
Yeah, exactly. And they're watching their colleagues going home, right? Quite a big moment for them too, right? Because of course they want a safe and smooth return of their colleagues.
Yeah, exactly. So you can see that on the left of the screen is a video stream from the camera mounted in the re-entry capsule inside the cabin. So we can see that the 3 astronauts of the Shenzhou-19 crew is sitting in their seats, and also the commander Cai Xuzhe is reading the menu.
Right.
So they are very calm, and I believe that at this moment they are still very comfortable because still in the microgravity environment. And on the right, as you mentioned, the Shenzhou 20 crew is watching the live coverage of China Media Group, and it is very interesting, you know, that during the landing before, actually speaking, during the landing of the Shenzhou 15 crew, the Shenzhou 16 is watching the live coverage, and your colleague anchor in the studio of CMG say hello to Mr. Jing Haipeng, the commander, and he can respond. So it's very interesting.
Actually, they got a real-time response, right?
Yes, exactly.
Okay.
So no, yes.
Almost a real time, right? Because there will be some
maybe
latency.
several seconds delay.
Yeah.
But you look this video. So this is a camera mounted on the propulsion module of the Shenzhou spaceship. At this moment, still we can get the video because you know that on the propulsion module we have a high gain antenna which can send the wideband video stream from the Shenzhou spaceship to the Tianlian data relay satellite. So the definition is very high today, so it is very clear. Also, there are multiple video streams like the one on the left and those on the right. Not only we can see the video inside the cabin, but also have the one on the from the camera mounted outside. So you can see that they are still the Shenzhou spaceship in the sunshine area. So you can see that it is very bright.
And I believe it's fair to say and quite evident that monitoring during the whole process is of great importance to the success of the whole landing mission. But we do have this knowledge of going through this so-called blackout zone. So since, as the name entails, I believe no monitoring is available during that stage?
It just means they can't send out information. It's roughly because the spacecraft is going through air really fast. It's pushing air and heating it up, so the air becomes ionized. So electromagnetic waves can't pass through because they will transfer their energy onto the charged particles. The charged particle field waves. That means they can't broadcast, their health conditions. They can't send out, Beidou location information, that sort of thing. But you can still see them. And after Shenzhou 12, the ability of the ground crew to just use visual and other means to triangulate where they are is good enough that you really don't need them to tell you much. It's really nervous for us, not knowing what's happening there. Not so much.
technical process.
Oh, right.
Well, from the voice, we can hear the commander announce the first prediction of the landing location. Usually the whole landing procedure from the just we witness of the deorbiting maneuver, we need usually 4 to 5 times to have the predict of the location of the landing site. Because you know that although we have a theoretical landing point, but that's only a theoretical one. So it was influenced by all kinds of disturbance, either from the error of the engines, also from the aerodynamic forces. So just along the trail of the Shenzhou spaceship, we need the ground stations, we need the data relay satellites, and also we need the inertial measurement unit inside the cabin to measure the trajectory. And also with this prediction, we can help the ground team, the rescue team, to get to the real landing point with the fastest speed. So this is very necessary.
Yeah, talking about ground team, actually we're watching live footage from the ground team, right? Yeah, we got a higher bird's view. I believe the ground team is on their way to the projected landing site right now.
So according to the announcement of the team yesterday, this time is a little bit different from the previous ones.
Right. So now let's get more on the Shenzhou-19 mission first, gentlemen. And China's Shenzhou-19 manned spacecraft and has left the China space station this morning, Wednesday morning, and is expected to return to Earth very soon. Crew members Cai Xuzhe, Lingdong and Wang Haoze will touch down at the Dongfeng Landing Site in northern China's Inner Mongolia Autonomous Region. During their 6-month mission, the Shenzhou-19 crew completed many tasks. They handed over work to the Shenzhou-20 crew, which arrived to the space station last week. And as we can just watch the live footage, the 3 taikonauts, the Shenzhou-20 taikonauts, are also watching live footage of their colleagues' way home. And the return of the Shenzhou-19 was originally scheduled for Tuesday, but was postponed due to unfavorable windy weather. Authorities elaborated on the change of plan.
Just as we establish minimum conditions for our launch missions, we also set minimum conditions for the return missions. Typically, our return system requires that the average wind speed does not exceed 50 meters per second. If this threshold is exceeded, we must initiate contingency plans.
Meanwhile, the Dongfeng Landing Site in the Mongolia Autonomous Region is all ready to welcome the Shenzhou-19 crew home. A final comprehensive drill was conducted at the site. The Shenzhou-19 crew has completed all its planned tasks in space. New equipment is in place in the landing site to assist with the Shenzhou-19's return.
We have new equipment. The 5 helicopters participating in this mission are all high-power models suitable for plateau operations, with overall performance superior to previous mission vehicles. Moreover, we have comprehensively updated the payload equipment installed on our air unit helicopters and ground unit search vehicles, upgrading all terminals to Beta 3, which provides higher precision positioning and timing services for air and ground units, presenting more accurate and real-time situations to our command center. We have also added a laser weather radar system around the landing site, greatly improving the accuracy of landing point forecasts.
The synchronization requirements between the landing point of the re-entry capsule and the search and rescue forces are relatively high for the return mission. We implemented data persistence management to achieve precise traceability of the mission data. At the Dongfeng Landing Site, which features complex terrain, we synchronized the presentation of the mission situation, assisting the command center in understanding the search and rescue progress and providing guidance information to the rescue teams to ensure a smooth mission.
Now you're watching live footage from right outside the return capsule of Shenzhou-19 spacecraft. 3 Chinese taikonauts are on their way home, and they all belong to the Shenzhou-19 mission. And professors, I think as the 3 taikonauts are on their way home, it's perfect timing to take a look back at the whole Shenzhou-19 mission. As an astronomer, Professor Zhang, what are some of the scientific and technological experiments, tasks you paid most attention to this time?
Right, there hasn't been any specific astronomy things going up, but in the future there will be something called the Chinese Space Station telescope that will go up and fly in the same orbit, and occasionally come in and dock with the Tiangong station and get repairs, upgrades, and replenishment of fuel. So that's something I'm really looking forward to. And each time, because you can't really go into the telescope. It's filled. It's solid. So the astronauts will have to do the maintenance by doing spacewalk. And this time they did a spacewalk lasting 9 hours. I believe that's a world record or something. They had to repair a stuck payload adapter from earlier sort of payload-only missions, in and out cargo transfers, and then they did a wonderful job, and they managed to stay out there and working in perfect conditions for 9 hours, and that experience built up the relaxing of the envelope of how long you can stay up there. Right. Will become really useful when you are handling a complicated machinery as complicated as a space telescope. So that I have been really nice to see.
Right, and Professor Yang, still focusing on this 9-hour-long spacewalk conducted by the Shenzhou-19 crew. Explain to our global viewers, how significant is this?
As Professor Zhang has already mentioned, it's a world record. That's one amazing thing is that, that the designed time for one single EVA is 8 hours. But how can we conduct a 9-hour EVA? This is because that for any space activities, either for the design of a EVA spacesuit or for a spacecraft, we must have a design margin. So to ensure the safety and ensure the success, this is very necessary. With this margin, we can have the right resources to stay longer in outer space. That although it is the designed life for one single one is 8 hours, but with this margin today, because the technology is already very practical, so we can ensure the safety of our astronaut even for 9 hours. The interesting thing is that, that this is a very important success for us in the future, that if we conduct more challenging tasks outside the cabin, if we make something difficult, and that there are many uncertainties during a very complex EVA. So to dealing with this EVA, you may work longer than expected. So with this margin and with this attempt to work longer in outer space, it is really meaningful for us to facing these challenges and facing these uncertainties in the future. So it's not only a world record, but also very practical in the future. Moreover, you see that one more thing amazing is that, that the design, the lifespan for one the second generation Feitian spacesuit is 15 times within 3 years. But that today we've used one of our Feitian spacesuit for 17 times. Even 17 times, it's still in a very good status. So this shows that it proved that the design and also the manufacturing, testing, and the maintenance of our second generation Feitian spacesuit is very, very good. And also it has the experience very helpful for future lunar mission. That our lunar missions use the Wangyu EVA spacesuit. So it is also have the right experience and knowledge we get to have a better development of the Wangyu EVA spacesuit.
And talking about the outstanding work of the 3 taikonauts of Shenzhou-19, Professor Zhang, what worth mentioning is that Wang Haoze, taikonaut Wang Haoze, she's a female, and she's at first, I believe, flight engineer to go up to the China Space Station. How significant is it? And tell us more about the responsibility of a flight engineer up there in space.
Right, so there are 3 types of astronauts. One is the pilot. Usually the commander will be a pilot. In the past few missions, there have been more pilots going up because they're training the 3rd generation pilots to become future commanders. But usually you would have you would have a pilot, you would have a flight engineer, which takes care of the spacecraft, the engineering aspect of it. Wang Haoze, she used to be a designer for new concept spacecraft. So she really knows the ins and outs of how things work, and it's very useful to have, especially when you have to have unexpected situation, unexpected improvement, or improvement you want to make, to have somebody who knows how the station you work in actually works. And then the third one is usually a payload specialist, who's there to do nothing to do with the flying. It's more to do with science experiments. In the future, that might become a scientist, even from different countries. So it's the significance of this is it's gradually transitioning towards a more sort of regular, different roles, multi-role crew.
Right, and as gentlemen, as we're talking about this, we're watching live footage on your left hand of the screen is live footage coming outside the Shenzhou-19 spacecraft on its way going back to Earth, and now you're watching it full screen now. Professor Yang, tell us more about the scientific and technological experiments conducted by the Shenzhou-19 crew this time. Earlier, before our chit-chat ahead of this live broadcast, you particularly mentioned experiments in condensed physics.
Exactly. You know that condensed physics, including the devices and also the instrument for this study, and also the quantum science, is very, very important, but also very, very challenging if we conduct this kind of experiment in outer space. So you know that the temperature we achieved in this ultra-cold physics can reach to about several pico-Kelvin. So this is a very high parameter for this kind of experiments in study. You know that just in the previous video, we see the camera, we see the video stream from the inside the cabin of the re-entry capsule. You know that this time we will bring back more than 100 samples from this whole Shenzhou-19 mission. So these samples, some are derived from the space medicine experiments, some from the space biology experiment, also some from the space physics. So you know that in the future, as Professor Zhang already mentioned, we will have what we call a Chinese version of Hubble Space Telescope. So the advantage is that, not like the Hubble Space Telescope, you know that the Hubble Telescope orbiting the Earth in a different orbit comparing with the International Space Station. So the International Space Station can do nothing to conduct the maintenance of the Hubble Space Telescope. So with the retirement of the space shuttle, so the United States cannot conduct any maintenance and repair of the Hubble Space Telescope. But you know that the Xuntian module in the future, or the Chinese Hubble Space Telescope will orbit the Earth with the same orbit of the Tiangong station. So it's very easy, and also with low cost, we can conduct any repair, upgrades, and also maintenance of and refueling of our Xuntian module. And moreover, you know that although the diameter of the mirror, the main mirror, is only 2 meters, very similar to Hubble, but the field of view is 100 times larger than the Hubble Space Telescope. So it can have more information than the Hubble Space Telescope. So this is the advantage of our future scientific research. Also, as you have already mentioned, look at this video on the right. You can see that the Miss Wang Haoze just sit the most close one to the camera. And we are very proud because you know that I am from the industry. Also, Ms. Wang Haoze is the designer of new rocket engines. So she has very comprehensive knowledge, not only in the design of a rocket, but also conducting all these kind of very complex scientific research.
Right, and they're still waiting. I think the spacecraft is now still waiting for the next stage, crucial step of their re-entry. Just to make sure with you, Professor Yang, they're not re-entering the atmosphere.
Not now.
They're still waiting for the right moment and several key technological steps to...
They are still outside the atmosphere. At this moment, still the propulsion module is connected to the re-entry capsule at the altitude about 145 kilometers. I believe within 1 or 2 minutes, we will conduct the separation between the re-entry capsule and the propulsion module. So this, as you mentioned, this is another critical step because you know that the Shenzhou spaceship conduct a 3-module design. So the only the re-entry capsule will be recovered. So the propulsion module will be jettisoned several seconds later. Right. I believe within half a minute.
Yes, and now we're watching live footage from the landing site, this is kind of a bird's view, highly likely from the helicopter.
Yes.
And the ground team is on their way to the projected landing site, waiting for the return.
Okay.
Now we've got the confirmation, right?
Exactly.
Yes, Professor.
So we heard from the ground commander that the propulsion module has successfully separated from the re-entry capsule. You know that if it is recovered at night, like the coverage we conducted before, you know that because we only have the heat protection on the re-entry capsule, so the propulsion module will come into pieces. And usually, you know that in the live coverage before, we can witness that for the re-entry capsule, we can see a very bright spot. But you can see that there is a very beautiful trail just behind the spot. So
and talking about landing at night, Professor Zhang, how challenging is that? Because in daylight time, of course, you're talking about visual and things like that. It's easy to understand. But what about nighttime?
Nighttime, mostly it's the temperature that really last time that was the most.
Makes no difference to the whole monitoring process.
Not really too much difference, I would say. You know, the temperature, the helicopter, you need to turn it on every hour or so to make sure it turns out right. And then I guess they need some visual for flying and driving on the ground, you know, through shrapnel. It's off-roading, they don't have road. So that bit is a bit challenging. But otherwise, for the re-entry maneuvers, it doesn't make too much of a difference.
Right, so as we just heard from the Command and Control Center, the re-entry capsule has separated from the propulsion module. So is it fair to say that they're almost to re-enter the atmosphere?
Exactly. So I believe that within several minutes, they will touch the roof of the atmosphere. They will enter the blackout area very soon. You know that at this moment, usually we will have a second prediction of its trajectory, because you know that the separation itself will have some disturbance to the trajectory and also influence the coordinate of the landing point. So usually at this moment, the ground control will announce the second prediction of its trajectory. We heard the voice from the ground control. And as you mentioned, this is a video from the helicopter in the landing zone area. This time, as your colleague already mentioned, it's a little bit different. Still, the ground control is announcing the information to everyone. And you know that the eastern part of the landing site of the Dongfeng Landing Zone is a little bit different from the usual ones. Usually, we conduct our recovery procedure in the western part of the Dongfeng Landing Site. Okay, our ground station has already captured our target, the re-entry capsule.
Yeah, but Professor Hao, because it's still not in the re-entry stage.
Right, it's still outside of the atmosphere.
Yeah. So by identifying the target, of course, that means the return capsule. And now I believe Command and Control are
announcing the coordinates.
Yeah, confirming the landing site coordinates.
Exactly. I just heard that, you know, that's this prediction, we have, this is the second prediction of the landing coordinate. And you may notice that the longitude is 101 degree. You know that during the previous recovery of our Shenzhou spaceship, usually the coordinate of the landing point about 100 degree. So this time is 101 degree. For 1 degree is a little bit different to the eastern part of the landing site. You know that one thing we should consider is that the terrain in the eastern part of the Dongfeng Landing Zone is quite different from the western part. The western part is relatively flat, but in the eastern part, the terrain, the shape is more complex than the western part. But you know, we don't have other choices, because you know that every day, if we want to have the return, the landing point will be different from the previous day. Because you know that the basic...
now we actually see visual from the
ground. Yes, this is an infrared video image from the ground station. We can see the bright spot is a re-entry capsule. We can see the long trail is, as Professor Zhang has already mentioned, is the plasma produced by the high temperature.
So is this in atmosphere now, the return capsule?
It's already in the atmosphere.
Yeah, because we can see the long trail now, right? Yeah. Oh, the capsule is in the blackout zone. So for this stage, we cannot see live feed out from the capsule itself.
Well, you wouldn't see the videos even after the separation because the antenna is on the service module.
Right.
But now even the radio is cut off.
Look, you can see that just
the bigger, brighter
is the beautiful view is the debris of the propulsion module, because it do not have a heat protection.
Yeah.
So it will break into pieces with a
burnt out
in the atmosphere. And burn out. So this is like a meteor shower.
Yeah.
So it's very beautiful.
Yeah, quite an exciting moment. So this footage is from a ground observation, right?
Yes.
Okay. So what's the standard time calculation for the blackout period?
Oh, we just heard the voice. One ground station has already captured our Shenzhou spaceship. So usually from the orbit burn to the landing, usually we conduct to about 40 to 50 minutes. So it is a very long journey, more than 10,000 kilometers. You know that because usually for our Shenzhou spaceship, the normal return, we call this semi-ballistic or the semi-lift re-entry, because the symmetrical axis of the capsule, the capsule is like a bell, so it has a symmetrical axis. Usually, it's have a deviation of the center of its mass from the symmetrical axis. So during the re-entry, there is an angle between its flight direction and the axis. So we will have some lift. With the control of the attitude of the re-entry capsule, we can control the direction of the lift and then adjust the landing point. So it is a controlled one. And we can, although that there are some deviations, but we can control with the control to close as possible to the theoretical landing point.
Indeed, and we're getting closer and closer to the landing of the Shenzhou-19 spacecraft. And for more on that, let's cross live to our reporter Li Shuang, standing by at the Beijing Aerospace Command and Control Center. Li Shuang, bring us up to date.
Well, hello again, Pan Dong. As we anticipate for the final landing of the Shenzhou-19 capsule, the responsiveness of the Beijing Aerospace Control Center is on full display. Earlier, we heard that multiple stations across China have spotted the capsule, and we also heard the captain of the Shenzhou-19 crew reporting back to the control center saying that their condition is stable. Now, that is obviously a very good news. What we're about to witness is the capsule re-entering the Earth's atmosphere, and as well as the aerial braking kicking in at about 10 kilometers, and also the deployment of the main parachute. Now, like I mentioned earlier, for the first time, the capsule will be landing in the eastern zone of the Dongfeng Landing Site. That obviously presents new terrain as well as new challenges, but the teams across the mission, from the engineers here at the Beijing Aerospace Control Center to the search and rescue teams out on the front, they're all working closely together to ensure that everything is ready. They've also run full rehearsal and deployed air and ground recovery team. They've also adjusted the plan with precision. Now, we learned from the final rehearsal that within minutes of receiving simulated coordinates from the Beijing Control Center, a helicopter swooped in to secure the landing area, and also nearly 100 vehicles, including command trucks as well as search and rescue units, also were deployed across multiple routes. Now, that is obviously something we're expecting to see shortly. What we're also expecting to see upon the landing is the ground teams opening the capsule and helping taikonauts out and swiftly transferring them for medical checks. Now, currently we're hearing a lot of real-time commands and receiving. We're seeing that the Beijing Aerospace control center is sending out real-time commands and receiving information from different stations. And now we'll be standing by here and closely following the descent of the capsule and bring you up to date. Back to you, Pandong.
Thank you very much. Our reporter Li Shuang in Beijing Aerospace Command and Control Center. So, gentlemen, let's talk more about this. I think we're still waiting for the return capsule to go through the blackout zone. Right. And after that, is it a step of opening the parachute, Professor Zhang?
Right, that will happen at around 10 kilometers above ground. So once they come out of the blackout zone, the intense deceleration will bring them down to like speed of an aircraft. That's still too fast to hit the ground with. So once the parachute is deployed, that will bring the speed all the way down to like 7 meters per second, which is brisk running. It will hurt. It's survivable, but it's not ideal yet. And then the last step is there's going to be a solid retro booster at the very end, 1 meter above ground, and then that will bring it down all the way down to 2 meters per second, and that'll be fairly comfortable to the land.
Right, and just several minutes ago, we heard confirmation from the command center saying that the airborne team is already standing by at the projected coordinates, as you just mentioned, 101 longitude, right?
Yeah. Oh, great. We've already seen the deployment of the parachute. Look the beautiful view. So the main parachute has already been deployed. At this moment, it's already below, the altitude is below 10 kilometers.
10 kilometers, right.
So at this moment, we can say that the astronaut is already safe enough.
Yeah, and that, I guess that's partially why now this spot is looking much bigger.
Exactly.
Compared to earlier stages.
What you see is not the capsule itself.
It's a huge parachute. It's a huge
parachute. So the total area of the main parachute is more than 1,200 square meters. So you can how big it is. Bigger than the basketball field.
So I guess that's totally designed to the payload of the capsule itself, right?
Exactly. So at this moment, you know that. So that's what we mentioned about when we talk about the wind. You know that on yesterday, because there are very strong winds, so there will be very serious influence of the wind to the trajectory, especially after the deployment of the main parachute.
Yeah. Now, I think they've just disconnected the main parachute, right? And opening another parachute?
Sorry, I made a mistake. So that's the drag chute. So this is the main parachute.
Oh, this is the main parachute.
Exactly.
Okay, now obviously we can see this is optical. This is not infrared. So I believe if we are on the ground, so with the sky is clear, and we can see that with our naked eye, right?
Exactly.
Yeah.
So this is a I believe this is a big camera, but also as you mentioned, we can witness of the whole parachute and the reentry capsule with your naked eye.
Yes, and as it entails on the upper right corner of your screen, it says it's the optical signal.
So visible the camera in the visible light band, and also as we have just heard from the ground control, for the third time they have the prediction of the coordinate of the predicted landing point.
Yeah, you have to be precise and have to adjust everything in real time so you can get there on time,
mentioned,
on place.
The prediction will be conducted 4 to 5 times to help the ground rescue team to get to the real landing site as soon as possible.
Right. Yeah, talking about size of this main parachute, you can see how big it is because
1,200.
Yeah, you would imagine a capsule is big enough because at least it has to hold 3 taikonauts and their necessary equipment.
Yes, exactly. Yeah. So you know that the total mass of the re-entry capsule is more than 3 tons. A big one. Although you look is very small like bell, but still for this re-entry capsule we need a very big parachute because we use a single parachute. For the next generation, we call the next generation our spaceship. We will use multiple parachute because it will be connected for the lunar missions. So the re-entry capsule is much bigger than our Shenzhou spaceship.
Right.
So today, even
I'm talking about payload. Sorry, Professor. I'm talking about payload. Professor Zhang, earlier, of course, before the re-entry, we saw the disconnection of the propulsion module of the spacecraft itself. But talking about this return capsule we're looking at right now, talking about its payload, it still has some propulsion module or segments designed onto it, right?
It's for adjusting its attitude, its orientation and stuff like that.
Right.
And then also the last sort of retro. They're really
to cushion
simple
the,
stuff.
the impact, right?
Yeah, they're not very powerful.
Right. Nothing major, but got some.
Right, and they have few, and which is why soon-ish you will see them dumping the residual fuel because it's toxic. You don't want that to spill.
Right.
And yeah.
Yeah, it's about to land.
What
we just
what
heard
Professor
from
Zhang mentioned is called a monopropulsion system. It uses hydrogen. Hydrogen as a propellant. So the hydrogen is toxic. So before the landing, we must really, you will see a white fog maybe several seconds later.
Yeah.
So that
it's about to land
because
we just heard
all of the propellants outside. No, this is the heating shield, the main heating shield. We just jettison the main heating shield.
Right.
Because we, as Professor Zhang has already mentioned, we need solid 4 rocket motors to continuously slow down vehicle when touchdown.
Yeah, now the heat shield is gone, right? So that signals the landing is quite imminent.
Exactly. So to expose the 4 rocket motors. And you know that even with this huge parachute, it's still too fast when touchdown. So that is the reason why we need 4 retro rocket. When the distance between the vehicle and the Earth is about 1 meter, we will ignite the 4 rocket engines, and the speed of the vehicle will slow down to slower than 2 meters per second.
So the control could be that precise, just 1 meter above, with this 3-ton payload, just when it's only 1 meter, and the ignition will happen.
The ignition, very good question, very professional. You know that just on the bottom of our re-entry capsule, we have one device called gamma ray altimeter. So it will emit gamma ray to the ground, and with reflection, it have a receiver to measure the time. So we can have a very precise measurement of the distance between the bottom and the ground. So it will send signals to ignite the 4 rocket engines and will slow down the vehicle to, as mentioned, less than 2 meters per second.
Right, and that's automatic?
Yeah, this is completely automatic. And you know that after landing...
No, we're actually doing the altitude countdown right now, 4,000 and still decreasing.
So this is a parameter sent by the Shenzhou spacecraft to our ground center. So you can see the very precise measurement of the distance between the bottom of the re-entry capsule and the ground.
And you can, from the countdown, you can see that the descent is really, really fast.
And you may notice
that we got to zoom in on the capsule.
We will deploy another rope, and attitude of the capsule will be changed a little bit from a lean one to a vertical one. So this is also to help the touchdown.
Sorry, is this in vertical mode right now? Because it looks straight up with the parachute on.
Yeah, so the parachute, the parachute bay is actually off an angle, which is why initially it was tilting a little bit. As Professor Yang was just mentioning, they have another rope to put it up. So
now that's the discharge of the
propellants,
fuel,
hydrogen.
Yeah.
Because it's
for safety precaution.
It's toxic, but it's necessary. You see that, as I mentioned, it is a controlled re-entry. So as Professor Zhang mentioned, we can control the attitude of the capsule during the re-entry. This is the function of the propulsion module, propulsion system on board the re-entry capsule, but only change the direction in the roll direction. To change the direction of the lift. With the change of the lift, we can change the trajectory to the landing point.
So it's not falling through atmosphere; it's flying through it.
Flying, yes.
And the engine is basically, as the like the aircraft wings changing the flipping up and down.
Right.
It's doing that function.
Right, but so I believe for a high stake mission like this, so a free fall is totally out of option,
only in emergency. It can happen if they need to get down really quick.
Yeah, hope that never happens.
it's designed to survive that, but it's survive and being comfortable with it.
Yes, yes. That's what we call the redundancy design, right?
Exactly.
You always have backup.
For manned spaceflight, it's necessary and reasonable to have sufficient redundancy measures. You know that always we think the life and the safety of our astronauts comes first. So although you know that it need more resources, the mass, the volume, but very, very necessary. For this one, we have a backup parachute.
Indeed.
But you know that for the next generation, we will use, because we will use multiple parachutes. So each of the parachutes can recognize as a backup and redundancy of each other. So it will be necessary in the future to master.
And even with those automation process you just mentioned, we can still do a manual override, right?
We have manual operations. We have the buttons inside the cabin. In emergency case, the astronauts can do these kind of things. So that is the reason the training is very, very necessary. You know that during an emergency escape, we will conduct the re-entry in what we call the ballistic re-entry. So the G-forces can be 8 times greater than their own mass. Even at this
impossible for common people like
as you mentioned, they must have the ability to do the right choice and press the button.
With that kind of gravity. And no mentioning the pressure.
Exactly. Remember, they've been in 0 gravity for 6 months. So it feels double hard.
Yes, exactly.
Unimaginable. Now, we can see the descending is going on very fast. And earlier, I think we saw footage from the ground team, from the ground vehicles. They're also heading to the landing point.
So we can have a very clear view of the parachute and together with the
because it's getting closer and closer, right? You don't need to zoom like 100 times to take a closer look.
So very beautiful. And you may notice, notice the background is a blue sky. Extremely beautiful.
Lovely weather, huh?
So it's very, very clear. And today the weather is much better than yesterday.
Now it's only less than 2,000 meters from the ground.
Correct. And so it is a reasonable choice to conduct the landing today better than yesterday.
Oh, of course. Safety is the utmost concern, right?
It's not even swinging that much, so the wind really died down. But since we're
that's
in Beijing,
absolutely good news, right?
Since we're in Beijing, we kind of understand weather's changed that quickly. But for our foreign,
just from the previous video, you may notice that Mr. Song Lingdong is sitting just on the right side of the command Cai Xuzhe, and it is that Mr. Song Lingdong is called 02, and it is duty of 02 to cut the rope of the parachute when land. So if it is just in the right moment, the advantage is that the capsule will stand there vertically. It will be very convenient for the astronaut. But you can seldom see this scenario because you know that only during the Shenzhou-6 mission and during the Shenzhou-13 mission, the moment they cut down the rope is the right moment and they stand there vertically. But for other missions, they just the capsules lie down
to a particular angle. But that's the common scenario, right?
This is a common
Standing
situation.
upright is kind of exception.
Exactly. But that's more convenient for the astronauts.
Yes, of course. Maybe taikonauts will feel much better. When
it's center of gravity is skewed anyways, so it's not. It doesn't tend
so
to.
this is also the reason why we need the assistance of the ground team, especially the medics, to help the astronauts to have what we call the readaptation of gravity as soon as possible.
Yes. And the whole, the full recovery of your sense to ground gravity would take even much longer, right?
At this moment, also, there is another critical step to just raise the seats of the 3 astronauts. Because you know that to absorb the energy of the impact.
Since you mentioned this, I must ask. Earlier you said it's the number 2 to cut the rope of the parachute. When you say cut the rope, you mean pressing a button or actually doing some standard maneuvers in that capsule to do that?
Well, you know that as we discussed, the wind is very, very dangerous for the whole landing procedure. And not only during the descending procedure, but also that after touchdown, the wind can be a big problem. So it can drag the whole capsule to a different place. So if it is in the mountain, it will be very, very dangerous. So it is necessary to
cut the rope. Cut the rope. You mean pressing a button to do the thing, or actually you have to do a standard maneuver?
That as I mentioned, the seats will be raised to absorb the impact energy. So the position of the bottom will be different when the seats are raised. So this is the difficulty and the challenge for 02 to conduct this operation. It will touch down soon.
Yeah, very soon. It's only about 500 meters above the ground.
It is just pushing the button. It's not going to go out there.
No.
But
impossible.
If it didn't manage to do that, somebody would jump off the helicopter and actually do that, cutting off.
At this right moment, the velocity of the capsule is usually less than 10 meters per second, but still too fast for the astronaut for the touchdown. So the retro rocket,
they've just adjusted the coordinates of the specific landing position.
They're just announcing, I mean, this is the fourth prediction.
And I believe the calculation is in real time, right?
Yeah, exactly. So the ground team, the whole ground team will be guided by this prediction.
This is totally within approach if you're standing on the ground, right? Yeah. Really, really close.
Yes.
Wow. That's descending really
So the retro rocket will ignite soon.
So this is optical, right?
Yes, this is
from the helicopter.
From the helicopter.
Right.
Yeah, it's already above the re-entry capsule.
Yeah. Since you mentioned earlier, the terrain looks indeed a little bit different
from the
common part. To the common landing site we've known.
Yeah. So it's more close to the Badan Jilin Desert in my homeland in Mongolia.
Oh, it's about to land.
Yeah. Oh, we can see the shadow.
Yeah. So cut the rope.
Ignition.
Oh.
Great.
Let's see if it's Now, the Shenzhou-19 return capsule has landed in Dongfeng Landing Site in northern China's in the Mongolia region again. This just happened. The Shenzhou-19 crew has returned to Earth 3 taikonauts and now on the ground in northern China's in the Mongolia region. So far, this has been a successful landing, right,
as you
gentlemen?
Mentioned, as we already discussed, you may notice the rope connecting to the parachute has already been cut down.
Yeah.
So this is a very successful touchdown.
Yeah, and we can see the ground team is rushing their way to this specific landing spot.
Yes.
Yeah, but the aerial team is already standing by, right? We've seen aerial footage from the helicopter.
With this video, we can prove that the helicopter is very, very close to the capsule.
Yeah, and we captured, the last several stages of the landing.
Oh, this time still it's not a vertical van.
Yeah, but this is the common scenario,
it's the
right? Yeah, it's the common scenario. Yeah.
I believe the 3 astronauts are in good status. Oh, we can also see the shadow of the helicopter.
Yeah, and we got.
Already.
So we can tell that there's the helicopter. One helicopter has landed.
Yeah. Usually, after the ground team reach the capsule, first they will remove the radiation source of the gamma ray activator because it's hazardous to everyone.
Right.
So we will use a container made by lead and to protect the blockade radiation.
Yeah, and having said that, another helicopter has landed. So we can say that at least the 3 helicopters are on site, right? One has landed, another one is about to land.
There will be 5.
There will be 5. There will be 5.
Helicopter would be the one flying and showing the pictures.
Yes. Another helicopter.
There are more than one helicopter has already landed. You know that in the previous missions, we usually have 4 helicopters, but this time we have an additional one. So the one helicopter will act as a commander, and it will have medics in the helicopter to help the astronauts at the first moment. Also, we have.
So the first responders. Let me make this clear. The first responders are from the aerial team, and a much larger team is coming from the ground team.
Right. Usually they're from different systems. Right. Some from the Shenzhou spaceship system, and some from the astronaut system. You know that all the medics belongs to the astronaut system because they will looking after our astronauts after landing to ensure that they are in good status. And also the Shenzhou, those rescue team from the Shenzhou spaceship system will looking after the capsule.
And ground team is still on the way. I think they're getting really, really close now.
Right.
Yes.
And the weather is really, really good. That you can also you can even see the shade of huge clouds on the sky.
Yes. The cloud is very, very low and very close to the ground.
Yeah. Oh, I can see. Yeah, another.
Because you know that the average altitude of this landing zone is about 1,000 meters. So it's in the highland, and usually you know that although it's already April, but very cool comparing with the weather in Beijing. So that is the reason why we, although it is windy and sometimes even have sunstorms in April, but it is reasonable to have the landing conducted in April, because you know that for the next crew, if we choose to May or June, of course the weather will be a bit better. But for the second team, for the next team, they will have to land on November or December, so that will be extremely cold. So,
but that's a test, isn't it? Because for systematic design like this.
Exactly.
Yeah, the aerial team has landed and they're conducting initial preparations, right?
So another helicopter landed in the Gobi Desert.
So at least 4 helicopters have landed.
And also there is a helicopter still, maybe this one, still hovering in the sky to have the video stream of the whole landing point.
Yeah. That's quite necessary, right? A bird's view of what's going on.
Have an overview for the ground control.
Yes. You can see first responders have already set up their equipment and doing initial work.
So you know that the ground team have some devices to measure the hazardous gases around the vehicle. As we've already discussed, you know that
there was a discharge.
It was discharged, but still maybe there's some remains. You know that it's gases, so it's in surrounding environment. Maybe there are some remained hazardous gases. So we have the device to measure. If it's dangerous, so we still need to wait.
And health.
Also, as I mentioned, for the gamma ray altimeter, we need to have a container to block the radiation.
You're watching live footage from northern China's Inner Mongolia Autonomous Region. This is the Dongfeng Landing Site, where the Shenzhou-19 return capsule has just landed. 3 taikonauts from the Shenzhou-19 mission has landed on ground, back on Earth, back on their motherland. So talking about this terrain here, Professor John, is this typical Gobi Desert? Because maybe we can see some plants going on, some bushes going on there.
This is quite different from if people watch the previous coverages. So further to the west, I've been even further to that, to the Qinghai Tibetan Plateau. It's raised sea bottom, so it's slabs of rock there. So it's quite easy to drive on, and shrubnel can't really grow on that. This is more regular desert. If you look at the terrain, it comes up and down, and there are shrubnels. So you can imagine
some bushes. And,
some bushes, So this is regular desert. So it's really not that nice for vehicles to drive on, which means they might take a little bit longer. Usually half an hour, maybe a little longer. Maybe
and we can see that is the return capsule. Shenzhou-19 return capsule on the right-hand side of your screen. It got very beautiful metallic reflection there, but I believe that's the result of atmospheric burnt-out, right?
Yeah,
they got
exactly.
some coating to stand that extra.
Yesterday we conduct the re-entry in daylight time, but you know that on the re-entry capsule there is a light beacon. But you cannot see that because it's in daytime.
We can see that now.
You can see that.
I can at least see one. Yeah.
So the ground team has reached the capsule, and they will open the hatch.
So initial testing of
the hazardous gas.
It's all okay for people to get nearby.
Yeah, opening the hatch.
Opening the hatch.
So you may
very soon we can see
the ground team from different systems, very different, the code in different colors.
Yes.
So they belongs to the different team.
Yeah.
Some belongs to the Shenzhou spaceship system, and some belongs to the astronaut system.
Right. So opening the hatch, and usually it was the ground personnel to enter first to check out.
But you know that the astronaut can also open the hatch when necessary from the inside.
Yeah, yeah.
You may notice that all of the ground staff are standing on one side of the re-entry capsule, because on the other side, there will be some exposure to the radiation from the gamma ray altimeter.
Yeah.
So it is necessary for a certain crew going to the other side and block the radiation.
Yeah, and of course that crew would have protection gear all over.
Exactly.
Right? Okay. Good, good. Now, talking about ventilation, I believe, of course, in space they have their own oxygen supply, but at this very moment, before the opening of the hatch, they're still using their own stocked oxygen.
Right, and in fact, one of the first tasks those white-coated personnel do would be to sample the air inside. So that's also indirectly sampling the space station air. So just so they can run tests to make sure everything is right. There's nothing weird in the air in the station.
You're watching live footage from Dongfeng Landing Site in Mongolia. This is the return capsule of Shenzhou-19 spacecraft. 3 taikonauts have landed, and now ground crew, as our studio guest just mentioned, are doing some technical checks before they open the hatch and meet the 3 taikonauts personally. I believe that's the national flag.
Although the Bio-like re-entry capsule is the total mass is more than 3
Now we can
times.
see the Chinese national flag is flying right next to the return capsule.
And also,
this is a moment of pride for
all
our
of
whole
us.
nation. Yeah.
Yeah. And you may
First
notice
of all,
also that still has some wind.
it's really a pleasure, and we're really happy to see the safe return of the 3 taikonauts. And what do you make of this landing process? Quite smooth, right, Professor Zhang?
It's textbook, and considering it's not a scheduled one, so they have to change the schedule last minute, and then also replot the landing. Also, you know, the wind tends to pick up afternoon, so the landing site choice and the trajectory maneuvers may not have been the optimal in terms of just the astrometry, the flight orbit stuff. You know, you have to pick your time and do something suboptimal in the technical aspect of things, and they still managed everything. You know, textbook. So it's really good.
Yeah, just to explain something to our global viewers, you can see on your screen on the left-hand side now on to the right-hand side footage of your screen. The Chinese national flag is flying on the left, and another red banner on your right-hand side. It says Dongfeng Landing Site, and this is exactly where the return capsule has landed. The technicians on the ground are still doing initial tests before they open the hatch. If all goes well,
it's open.
Yeah, the hatch has opened. And ground personnel will go in first, right?
The medics from the astronaut system will help the astronauts to get what we call the readaptation of gravity. So this procedure may need several minutes for that, because for different persons there will be different response.
Yeah.
Sometimes you know that they've already stayed in outer space in microgravity environment for more than half a year.
So impossible to work, right? At this very moment, right? And it takes a long time.
But theoretically speaking, they must have the ability to work, especially, you know, that there will be some uncertainty. If they conducted an emergency re-entry, it will be in a different places than this one. So maybe you have to need to wait to 1 or 2 days for the reach of arrival of the rescue team. So in these circumstances, you must have the ability to survive by yourself.
Yeah. But now the hatch has opened, and ground personnel now meeting the 3 taikonauts in the capsule.
So we just heard from the voice of the ground team. They reported the density of the hydrogen is 0. So it's safe enough for the ground team.
absolutely good news, right? Safe for everyone, to be honest. Yeah.
So this is important not only to ensure the safety of our astronauts,
exactly.
but also to ensure the safety of our all ground team.
Indeed, I believe hundreds of people on site right now.
And also, I believe at this right moment, your colleagues from the CMG has also arrived at nearby places to prepare the interview with the astronauts.
Yes, that's part of our job description.
Yeah.
Be there.
A traditional step.
Well, look at the terrain, it wouldn't be a nice ride, so they really did sacrifice as well.
But you may notice from the national flag that the wind at this moment is also a little bit strong.
Not exactly mild, huh?
Yeah.
Yeah, and this is typical in northern China. If you want to have clear skies, sometimes you got to be windy to get blue sky.
You don't have much more choices.
Yeah, you don't have a perfect balance between a very mild weather, blue sky.
But at least this today without any sandstorm.
That's good, right?
Yeah. And so the sky, also the terrain is very clear.
Yeah.
For
this
the
is a
rescue.
very beautiful natural setting. Blue sky, white clouds, with the Chinese national flag flying, and this beautiful return capsule with bringing back 3 taikonauts safe and sound.
Right.
Yes.
And it looks like the wind is gradually picking up, which means the choice of the landing window, really, the weather forecasting team, kudos to them, they really predicted it really well. So they cut really close to the to when wind picks up.
Exactly, I want to catch up on that because we know weather forecast, it's not exactly a forecast, right? It's just a prediction. It's about probability, right? So it's also a show of technological strength on how accurate, how close you can get your prediction to the actual situation, right?
So this is an achievement of the, as you mentioned, the whole system.
Exactly.
Not only the spacecraft itself, with the help of the ground team, of the ground stations along the trail, both inside and outside China, and also with our Tianlian data relay satellites, and also especially with the help of our Beidou navigation satellite system, we can have very, very accurate prediction of its trajectory. So this is very necessary support for the rescue team to get to the right landing point, even at the first moment.
Exactly. Finding the right window, get there at the right time, right place.
Right.
Yeah.
And also, that concerning the international cooperation with China, have agreement with many countries to have the deal that in the emergent case, we can land in other countries.
Right.
测量完毕，返回舱坐点坐标为东经幺度动4分动9秒，东经幺度动4分动9秒，北纬412度。
The ground team has just measured the exact coordinates of the landing spot.
Exactly, the final one.
Yeah.
You may notice the longitude, as I mentioned, is 101 degree.
Now it's kind of 4 minutes and 9 seconds.
It's
101 degree for
101 degree.
Yeah.
So it's 1 degree difference comparing with the previous landing procedure.
A little bit.
So for 1 degree is about 100 kilometers away.
Yeah.
100, actually speaking, more than 100 kilometers away. So this is the reason why we choose the eastern part, because you know that theoretically speaking, every day we have a window to conduct the recovery. But you know that for every day, because the trajectory will be different, the orbital plane of the King space station will be different comparing with the landing site. So every day we have a possibility to conduct a landing, but every day it will be a little bit different.
Now the ground crew are still checking the 3 taikonauts. Now from this position, it's very difficult to tell they're now sitting upside down or conversely. Yeah.
So ideally, the reason why people talk about landing it vertically is that because you lose your muscle, especially your heart muscle. Your heart doesn't need to pump blood that hard in space, and then so ideally, when they're sitting in a position where all the major arteries are at the same level as your heart. So it simulates the zero gravity condition. Actually, some of the cars, some of the business vehicles now sell this zero gravity posture you
Right.
can achieve in the car. So,
Right.
so it's the same thing. So which is also why when they come out, they will sit on a chair in that kind of a laying down position. So that helps their recovery.
Yeah.
我是北京，雄鹰
So
是两
nothing
只
is
脚
casual in a high-stake mission like this. Everything's well calculated, well designed, and well carried out.
And also, although everything is well prepared, but still, every system we must dealing with the possible uncertainty.
Yeah.
For instance, there are deviation of the coordinate compared with the theoretical landing coordinate and the real one. And also, you know that there are many differences, and also there are probably there is some malfunction of even a very small compartment will cause the deviation of the landing point from the design, the coordinate. But so everybody must prepare for that. Both the astronaut and the ground team must be trained before their flight missions to conduct. For instance, almost the most tough and inconvenient training of the astronaut is survival in wild field. Usually, our team before their flight, they will have to stay in the Badan Desert for 2 days. They must survive by themselves, and sometimes they even need to drink their own rain because there are only limited water.
Yeah. When you're in the wild, that's the thing you got to do, right?
Yeah. Although this is only unpredicted one, but they must prepare for that.
Yeah. Just as you said, we must exhaust all the humanly imagined possible scenarios before we actually send men and women up there.
In the real mission.
Yes. Nothing can be taken lightly. And that's why the ground team are checking up everything thoroughly.
Yes. So after this readaptation of gravity for the 3 crew members, according to the tradition before, usually the commander, this time Mr. Cai Xuzhe, will go out first. And then Mr. Song Lingdong, and then Ms. Wang Haoze.
Yeah.
So we've prepared 3 ground vehicles for each astronaut. They even have bathrooms inside the vehicle. So they will be looked after inside, and also the medics inside the ground vehicle will help the astronauts.
Indeed, after 175 days, you want some instant Earth feeling, right?
Yes.
Yeah, feeling like home. Huh?
Oh, I also see the beacon.
Yeah, the beacon, yeah. It's still blinking.
This is very necessary to send signal. Also, there were radio signals to announce the coordinate of the landing point from to help the ground teams to get there.
Indeed. And just as you mentioned, even on the ground, you have personnel from different systems, astronauts and mechanical things like that. You can't imagine the whole project, the workload on this systematic integration. That would be impossible for common people, outsiders like us to imagine. And you have to also lay out all those possible scenarios. You have to exhaust your imagination, wildest imagination, to prevent bad scenarios, bad case scenarios to happen. I think that's...
There are many branches for this scenario in different
That's why
cases.
this is a national project, right? And that's why the aerospace industry is being called, the crown, the jewel of the crown on any given industrial system.
Yeah, but this is, that's very necessary when we always, ensure the safety of the astronauts, or the life of our astronauts always comes first. And that for this is a contribution of the whole system, and there are thousands of people on the ground preparing for this landing. As you mentioned, even they have drill for many times to prepare this landing, and even they will prepare for the landing in very bad weather, and also as Professor Zhang has already mentioned, in the very extremely cold weather. So they have to prepare for that and for any uncertainty to ensure the safety. This is really necessary. One important reason is that for half a year residence in outer space, their cardiovascular system, their bones, and also their muscles are extremely weakened. Although we have necessary physical exercise every day.
But that's still your minor gravity situation. Nothing compared to the gravity on Earth. So
that the bodies of the astronauts themselves are also the objects for scientific research, for the medical study. in outer space. And they have many, they even have some, that some of the samples are their own blood. So they have already get some samples of the blood and other samples of space medicine and space biological study.
So 3 tachyonauts.
The sampling has already accomplished.
Yeah,
Xiong is the code
sampling
of
the air,
helicopters.
Air and microorganisms environment situation within in the hatch, right?
Right, and the surprising microbes in the space station is actually one of the major tasks they've been learning up there.
Right.
It's a room, It's like your bathroom. These things grow.
Yeah.
And it's not easy to clean when you're in a space station where everywhere is a crevice.
Yeah.
So you don't want that to happen.
Yeah. One important factor that the cabin has already parked on the space station for half a year. So as Professor Zhang has already mentioned, they do have very great influence of the microbes to the inner side, to the inner volume of the re-entry capsule. Maybe there are some growth of the microbes, and also that there are hazardous gases inside the cabin. We have an environmental control and the life support system, but still, that is still in improvement for every time. So in the future, I believe that our environmental control and life support system can be also continuously improved in the future to be more comfortable, to be more safe for and be more healthy for our astronauts.
Indeed, and that would be a constant process because China is reaching higher and higher standards of its space missions. For example, we just talked about these experiments, scientific experiments conducted on the Tiangong space station by the Shenzhou-19 team. They're getting more and more complicated and comprehensive.
Quite right.
Chemicals, physics, life sciences, material science, everything's in there, to be honest.
Yeah. One important experiment, that although it is the task of the Shenzhou-20 crew, but I believe that that just after the arrival of the Shenzhou-20 crew, that's the Shenzhou-19 crew this time stayed 6 days together with the Shenzhou-20 crew.
Right.
And I believe that this time the Shenzhou-20 crew brought for the second time the zebrafish to the space station. And according to the report of your colleagues, the experiment about the zebrafish has already been conducted on board the Tiangong space station. So I believe that the Shenzhou-19 crew also helped the Shenzhou-20 crew for this very challenging experiment.
Indeed, and talking about future experiments, I believe, Professor Zhang, you're anxiously waiting for that China Space Telescope, huh?
Yes, I am. It's a survey telescope, which means they look at the sky with large angle, so you can catch the flashy things just exploding without having to zoom in and concentrating on the same source for months and months and then to pick up enough signal, which means, well, all the exciting things are temporary in the universe. Explosions, they're more extreme. So catching those things will be quite interesting.
I think it would be easier for the public to understand sending people out in space because sometimes you can see a direct transfer of those technologies into our daily lives. But tell us, as an astronomer, why we need to look into so deep into the space.
Right. So first of all, it's to get knowledge about how the universe actually works. So a lot of people think technology comes from need. We have a need, we have a desire, and then we make something. That's exactly the opposite of how it happens. If you look at sci-fi novels from the past,
indeed,
none of that is realized.
And in reality, sorry to interrupt, now they're installing chairs for the 3 tachyonauts. So I believe all the tests came out okay, right? Because they're about to move the tachyonauts outside the capsule. Yes, Professor Zhang, you were saying. Right. Looking into deep space, huh?
Right. So, but actually what happens is the other way around. You do something research, finding out how things work. Initially, it will look like it doesn't have any practical application. And then after you discover how things work, and then some people will begin to use that knowledge to manipulate things. At this stage, it's applied physics. It may still not be clear what you do with it. And after you can manipulate things a little bit, then engineers comes in and begin to think of things, and especially if you can make money out of it, a lot of people come in, and all of a sudden something just explodes. That's how things actually work, which is why you want to do just looking up into the sky in the first place. And then also, this space station has a lot of very practical technology experimentations as well.
Right. So sometimes, or most of the times, we really need to look beyond the horizon as we know it from our childhood, and to trying to look beyond it and find something out of our imagination.
Usually, that to talk about the scientific research, usually there are two categories. One for pure scientific goal purely, and the other is for engineering purposes. For the engineering study on board the Tiangong space station, it will be not only very helpful to our daily life and for the production of as you mentioned, the material and also other things on the ground, but also very helpful for the aerospace field itself. That as Mr. Yang Liwei, our space hero, has already mentioned, because she's the deputy chief designer of China Manned Space Program. So everybody going to the moon in the future in our China's lunar program, they will first stay at least half a year on board the Tiangong space station. So you can see that our Tiangong space station is not only the national laboratory for scientific research, but also a very ideal training bay for our astronauts who conduct more challenging missions to the moon.
Indeed, and I think that's why, since ancient times, we got this convergence of those applied science and the highest form of human thinking into philosophy. Because if you go back to the origins, we only have physics and metaphysics, and they combined into philosophy. That's the highest form of the existence of human mind, right? Because that's why we've been defined as human in this universe, because we can think beyond ourselves.
I can still remember that in one of the previous Shenzhou missions, we bring the simulated brick made by the simulated soil of the moon to Tiangong space station to find if it is adaptive in the vacuum condition. You know that although the environment outside the Tiangong space station is still a little bit different from the environment on the lunar surface, but at least it's still in the vacuum condition. And also there are radiation outside. So this is a good test bed for our future lunar missions. I believe that many of the instruments for our lunar missions will be tested first on board our Tiangong space station.
We can see at least one chair is ready for one taikonaut.
So this must be
one taikonaut is coming out of the hatch. So usually it's the captain, right?
Yes. So this is Commander Cai Xuzhe's second mission. His previous one is Shenzhou-19 mission. Also very challenging. You know that the Shenzhou-19 mission is the most important mission during the construction phase of our Tiangong space station. Just during the Shenzhou-19 mission, the Tiangong space station formed the T shape with the coming of the Wentian and the Mengtian module. Also, you know that Mr. Cai Xuzhe conducted 2 EVA during the Shenzhou-19 mission, and
that was extraordinary, right?
Extraordinary. You know that also Mr. Cai Xuzhe. What impressed me most that he's very brave. You know that during one EVA during the Shenzhou-19 mission, he and Mr. Chen Dong, the commander, have a simulation of the what we call a rescue during EVA. You know that for any EVA partners, they must hold the handrail at any moment to ensure their own safety. But for this simulation, only a belt connected Mr. Cai Xuzhe and Mr. Chen Dong, and Mr. Cai Xuzhe acts as the one simulated to be rescued, and he do not hold anything.
Just let go the handrail.
Yeah. So he's so brave that and full of confidence and full of trust to his colleague. So that impressed me most during the Shenzhou-19 mission. And this time he is the commander of the Shenzhou-19 crew. Also, you know that several days before, the 6th crew of the Shenzhou-19 and Shenzhou-20 meet together. Also, you know that both Commander Chen Dong and Commander Cai Xuzhe belongs to the Shenzhou-14 crew. They meet again in space.
我是北京，熊鹰，请讲。
and he recovers really fast. So he's 14 and 19 is 5 missions apart, so it's half a year each. So he's back on there in 2.5 years or something like that. Usually takes 3-4 years, a bit longer than this.
So that also partially tells his physical strength.
His physical is fit.
Yeah. And we can see one chair for one taikonaut is ready, according to usual routine. It's the captain coming out of the hatch first.
Because he sits in the middle, you can see how small and how narrow it is. Although it is the total mass is 3 tons, but still
it's
for
a very tight space, just enough to squeeze in 3 taikonauts.
Yeah. You know,
every gram matters, right?
Yes, and also that not only 3 people inside, but also they wear the IVA spacesuit.
Oh yes.
So very narrow space for them. So the commander sit in the middle, so he must come out first.
Yeah. Otherwise, the 2 people sit beside him.
One interesting fact for Commander Cai Xuzhe is that he's also the first one in Tiangong Space Station to eat the vegetable they cultivated by themselves.
In space.
Actually speaking, in Shenzhou-19 mission.
Right.
You know that the first time to grow the vegetables is the Shenzhou-11 mission.
Yeah.
But to ensure the safety, Commander Jing Haipeng and Mr. Chen Dong did not eat the vegetables they grew in the Tiangong 2 laboratory.
Right. Because it was a kind of a test run, huh?
I believe that that the ground team, the crew wear the white suit belongs to the astronaut system. Most of them are medics.
Yeah.
So they are take care of the astronauts.
Yes.
And they must be very careful because after 6 months in outer space, their bone must be very weak. So it's relatively easy to be broken compared with ordinary people.
Yeah.
So
you must be
they
professionally
must be
gentle with every move.
Very careful and very slow.
Yeah.
Yeah, which is actually a pretty big problem because you lose 1 to 2% of your bone mass per month.
Huge.
Yeah. So it's like aging. So inside your bones you have this mesh structure.
Yeah.
And when you lose that, it's easy to get fractures and stuff like that. So.
And as you just mentioned, even that chair is specially designed for a situation like this to hold up the taikonaut as they first landed on Earth after like this time 175 days in space.
Yeah.
Right.
Yeah. Today we are witness of.
It's not just for their comfort. Of course, comfort is one part of the consideration, but mainly that's for
medical.
Yeah, for medical and physical supporting reasons, right?
Today we have a very smooth return, but you know that they also must be prepared for an emergency return. In this case, the G forces during the re-entry can up to more than 8G. So all the astronauts were trained in this circumstance. Moreover, not only they must be adaptive for this 8G overload, they also can do the right choice, press the right buttons in different circumstances. So this is a necessary training for the pilots.
So there's absolutely no room for you to panic for even 1/10 of a second.
Quite right.
Yeah.
So especially that for Mr. Cai Xuzhe and for Mr. Sun Lingdong, they have the role to be the pilots. So for the pilots, not only for the normal cases, but for the abnormal cases, they can do the right operation in emergency cases.
Yeah, and for the lineup of Shenzhou missions, at least for the recent several years, we can see different lineups, right? Sometimes, now this time Shenzhou-19 got two pilots and a flight engineer, but the Shenzhou-18 got a payload expert.
Shenzhou-16.
Shenzhou-16.
Mr. Gui Haizhao is the first payload specialist.
Yes. Payload specialist.
But you know that.
But that's usually depends on the features of the mission itself, right?
It depends on different missions purposes.
Yeah.
Although you know that, as you mentioned, actually speaking, Mr. Zhu Yangzhu is the first flight engineer, but he also has a role of a pilot because he must be the backup of Commander Jing Haipeng.
Right, but this time it's a little bit different for Ms. Wang Haoze, right?
Yes, exactly.
She's kind of a dedicated flight engineer.
Yeah.
Okay.
And Commander Cai Xuzhe is preparing to go out.
Like we've just mentioned, after 175 days in space, your body certainly changes significantly compared to your daily lives in and out on the ground. So every move must be professional, must be gentle, must be careful. And that's exactly, we can see that very well-trained personnel from the astronaut system of the whole space mission are taking care of this very important stage. And after landing,
the Shenzhou-19 crew stayed one more day in Tiangong Space Station because of the bad weather yesterday. They should have been here yesterday.
Yeah. And talking about the ground vehicle welcoming them, you just mentioned, Professor Yang, one taikonaut will have his or her on a vehicle, and it was also kind of a routine for them to have something. Some food they really love.
Yeah.
Upon their arrival, right? That's the Chinese customary since ancient times, right?
Exactly. So you know that both Commander Cai Xuzhe and our flight engineer Wang Haoze, their homeland is Hebei province.
Right.
So I probably they will have some noodle maybe.
Yeah, there's also the common saying, 出门饺子回家面. So on the way out, people usually eat
departure
dumplings.
Especially for we people come from North China.
Yes, true. Yeah. And now it's the return.
Yeah.
So maybe noodles, huh? We can guess away at this moment, but we'll find answer very soon. And this frame is kind of very symbolic and meaningful, isn't it? Because the Chinese flag is flying high. Actually, the whole nation has been expecting their safe return, the three taikonauts.
You know that
they're the proud of the nation and the heroes we really look up to, right?
Yeah, of course.
Yeah.
You know that years before, before the Shenzhou 12 mission, we conducted re-entry in Sizhiwang banner, also in Mongolia, but in the eastern 1,000 to the east of this landing site. So today, the advantage to use the Jiuquan Satellite Launch Center at the landing site, the advantage is that you know that for the launch, we also need a rescue team to, in emergency cases, they will conduct the emergency escape from the launch vehicle.
Yeah.
And the advantage is that we can use only one team to prepare for the launch and for the return. So it can save a lot of money. Moreover, you see that with the development of the local economy, the Sizhiwang banner become more populated.
We can see that actually we've just got line communication from takonauts in the capsule. They all report, good physical condition. They're feeling well. It's the literally
03
translation.
Miss Wang Haoze, she's from her voice, she must be in good status.
Yeah. Very upbeat voice, huh?
Yeah.
Must have been exciting. It's first time up.
Yeah, first time up, and a safe return, right?
And during the
always feeling good to go back home.
Yeah.
And just imagine during the blackout, it will be like flames all around. There are two windows they can see outside. And it would be quite something to see.
It's the completely flaming situation around you, right?
Right.
Yeah, and you would imagine the temperatures is like what?
2,000, 3,000.
Yeah.
But still, you know that
I believe one taikonaut is coming out of the capsule. Let's see who.
Commander Cai Xuzhe.
Who he or she is. Usually it's the captain, huh? But let's be sure. The taikonaut is coming out of the capsule with the help of the ground crew, professional crew. Due to 175 days in space in almost zero gravity environment, the physical conditions of their body still need some time to carry out the adaptation to the gravity situation on the ground. Now you can see Cai Xuzhe, commander of the Shenzhou-19 mission, has just come out of the return capsule, and he looks really well and happily waving to the ground crew at site. This is Mr. Cai Xuzhe, the commander of the Shenzhou-19 mission.
He's really energetic at this moment.
This is a safe return, and the whole nation is.
And congratulations for his second flight.
Yes, yes. That's a big congratulation, right?
And one interesting thing.
And this is a very intense mission as well.
Exactly. And one interesting thing for Mr. Cai Xuzhe is that he, during the interview before, he already expressed his wish to walk on the moon in the future.
Wow.
Welcome home. Two technonauts born in the 1990s were together with you and you completed your successful journey. What do you want to share with us? For numerous times in the space, we look back at this blue planet, which is our common homeland for man. We must protect it together, especially in the space station. We could see the stark red color, which is the brightest color in the space. We are so proud of our nation. And for this mission, I took two technonauts born in the 1990s. We worked as one to complete the tasks given to us by our motherland and the people. And in the future, we will continue such great efforts so that in this new era, China's space undertaking will have a new chapter. Thank you very much.
Now we just heard the immediate remarks from Mr. Cai Xuzhe, commander of the Shenzhou-19 mission, after his safe return to Earth. He said when he was in Tiangong Space Station, he looked over so many times, look at this blue planet, our home planet, and also he feels, this kind of urgency and strong necessity to protect planet, and also he feels so proud of the nation after this mission. And also, the journalist also asked him, what does it feel like in charge of the mission when your other two teammates are much younger than you, and I believe both Lingdong and Wang Haoze were born after the 1990s, so quite young. Huh?
Quite young.
Yeah, so this is very, I would say, a generational combination. Yeah. So usually you have a quite experienced and senior commander.
Yes.
You got to bring up the next generation, right?
Yeah. So both Mr. Song Lingdong and Ms. Wang Haoze belongs to the third batch of our China's technonauts. So the third batch, including these two members, we already have 10 of them out of the 18 in total have already visited the outer space. So they have very good chances because every year we have 2 missions. So they have been experienced ones, veterans, and next time maybe some of them will also act as the commander of a flight mission.
Yeah, yeah. And looking at this frequency of China's manned space mission, it raises higher demands for more and very well-trained taikonauts in the future, right? And also looking at the variety of the taikonauts themselves.
Yes.
Yeah, some could be pilots, as we just talked about, and we may need more payload specialists and flight engineers in the future as well.
Yeah.
Yeah.
But also, although we have the specification of pilots, flight engineers, and payload specialists.
And that's the vehicle,
the
designated vehicle, one for each, as you just mentioned, right?
Yeah, as I mentioned.
Now, another taikonaut is coming on. That's Mr. Song Lingdong. He's also a pilot of the Shenzhou-19 mission.
Yes.
Mr. Song Lingdong has just come out of the return capsule. He is the one of the pilots, one of the 2 pilots of the Shenzhou-19 mission. He's quite young, huh? As we just mentioned, born after the 1990.
Fighter pilot from the Air Force.
As a technonaut born in the 1990s, and since this is your first mission coming back to our Earth, what are you feeling right now? I feel very proud and happy and I'm full of hopes for our future. All of the efforts done by the scientists and researchers have been turned into tangible results. That's why I feel so happy and proud. And we completed the exit mission successfully for China to embark on the space journey. I am so happy to come on this journey on behalf of others. And I'm about to see my family that I missed for this long time. And also I will see my comrades who have always stayed with us during this mission. I'm really looking forward to seeing them. And I would love to thank all of them. Thank you for your hard work. And in the future, I would dive into some after work and I will readjust myself so as to be prepared to contribute my love to my motherland. Thank you.
Now, we've just heard immediate remarks from Mr. Song Lingdong after his safe return from space after 175 days working on the Tiangong space station. He said he feels very proud at this moment and he now has a lot of expectations to the future. And he also mentioned about the success of this mission, completed many scientific and technological experiments. He feels proud of the nation, and he also said he's very, very happy at this moment because now he's on his way to meet his family.
And you know that he also make a record. He is the first spacewalker of China who was born after 1990.
That's a personal and also a national proud.
Exactly.
Yeah.
So young, and you know that
it takes a lot.
It's always challenging for any astronaut.
Indeed, and it takes a lot to reach that step at this age, right? Yeah. Born in the 1990s.
And moreover, you know that for the 3 EVA of the Shenzhou during the Shenzhou-19 mission, it's really challenging to install the protection devices to avoid any collision of the space debris to our Tiangong space station.
Right.
And also, you know, this kind of there is another amazing thing that you know that we have a malfunction of the one adapter of the.
Oh yes, you mentioned payload. This. Let's talk about that. I believe it was a payload adapter. It was
stuck.
Got stuck. Yeah.
Got stuck when it was loaded outside. Yeah. So during one of the EVA, they just fix it. So that's the importance of the existence of human being in space missions. Yeah. So although with the AI technology and the automation technology, we can have more functions of the robotics, but still it is very important to have the attendance of human being inside. Yeah. So this is a very typical and very good example for show the importance of human being. Yeah. So it is very normal. You know that because the scientific research is very complex. Yeah. So the start of the adapter is, I believe that is inevitable because if you have more research works, sometimes we will have this kind of, we do have this kind of malfunction. But with the options of the astronauts, we can fix it.
Yeah, and this is a clear demonstration as well, right, Professor Zhang, of the professional capability of Chinese taikonauts. Because as much as you can practice on the ground, you cannot 100% to exactly copy the situation out of this atmosphere.
Right, especially as Professor Yang just mentioned, there's lots of experiments designed by lots of different people, designing things in lots of different ways and with different level of expertise in making things robust. So you just have to be flexible, be able to learn things and be able to stay calm. And it's a whole host of qualities that you have to possess to become a successful astronauts. And in fact, the Shenzhou-19 mission, they did some tests on the astronauts' ability to handle precision movements with their hands and stuff, and handle unexpected stressful situations, see if being in space actually make they lose that capability. So all of that is a gradual learning process for the whole program as well.
And one technicality is you have to hold tools and handling those precision tests and tasks with, you know, the whole space suits on with those huge gloves, right?
Right. the analogy is you're sitting inside of a fully inflated tire.
Right.
And then you move. The tire doesn't necessarily move with you. So.
Yeah, takes a lot. And I believe the third taikonaut, Ms. Wang Haoze, is about to exit the capsule.
Ms. Wang Haoze is the third female astronaut of China and the only one in the third batch of our astronaut team. And what pride me most is that, that like me, he's also an engineer from the space industry.
Right.
Actually speaking, she is a system designer of new rocket engines.
New rocket engines.
New rocket
Right.
engines. So she was working in an institute in Beijing to study the preliminary study of the advanced rocket engines. So she has very comprehensive, because she's a system designer. For a system designer, she must know everything. So her very comprehensive knowledge must help her in conducting the scientific research. As commented by Mr. Cai Xuzhe and Sun Lingdong, she is very perfect on every theory.
Having said that, taikonaut Ms. Wang Haoze has exited the capsule, the return capsule of Shenzhou-19. She is the flight engineer of the Shenzhou-19 mission. And as Professor Yang just mentioned, she's the third female Chinese taikonaut to go into the space. And she was also born in the 1990s.
Hello, Wang Haoze. As the first woman taikonaut to take on this mission, and also a young person born in the 1990s, what do you want to say to us? I feel so good coming back home, and also to feel the solid ground feels good. And now I am finally coming back to our land in the motherland. And I do want to say that my motherland, your sons and daughters who have gone very far are coming back. And in the last 180 days flying in the space, it was an arduous task, but I trained myself. And through this mission, I could be confident enough to report to my motherland and our people that I am capable of taking on more challenging tasks in the future. And please be reassured. During my stay in the space station, whenever I looked out of the window into the space, I felt firm that the Chinese takonauts would only go further and further, and we will certainly embark on the deeper space. And finally, I give my best wishes to China's aerospace business. I hope we could fly further and further, and also I hope my motherland could be prosperous in the future. Thank you.
Now we just heard immediate remarks from taikonaut Ms. Wang Haoze, the first female flight engineer from China to enter into China's Tiangong space station. She said it feels so great to return home, and he has reassured the nation and the people that she has fulfilled her tasks in space with her teammates, and she strongly believes that Chinese takonauts will keep going forward to reach more and more missions and tasks. And she also sent best wishes to the nation.
You notice on the seats there is a logo ACC, which is Astronaut Center of China.
Okay, right. Now, for more on this, let's cross live to our reporter Li Shuang, standing by at Beijing Aerospace Command and Control Center. So, Li Shuang, we can see that 3 takonauts have returned to Earth safe and sound. Tell us more from the command center.
Well, yes, Pandong, we just saw the 3